this lesson we're going to be covering absolute value functions and the graphs that are associated with absolute value functions. So for this first one, they just want you to have a general idea of what the absolute value function looks like. So if we made a XY chart of what it looks like when x is 0, y will be 0, when x is 1, y is 1, when x is 2, y is 2. When x is -1, the absolute value of -1 is 1. When x is -2, it's 2. So this graph will be a perfect V. So this will continue going up like that, and then also like so. Should be a sharp point right there. You'll have to excuse my hand becoming a bit of a curve there. This can also be transformed similar to all of our other graphs. This is talking about the absolute value of f of x. So we're going to have to make a distinction between the absolute value of f of x versus f of the absolute value of x. This is saying right here that if you take the absolute value of x when your y value is greater than 0, after you plug in the x and you get a y value, then you're fine. It's just still positive y's. But if your y value is less than 0, you've got to take the positive y version. You have to take the negative of that. So just a quick little sketch. If I had something like this as my function, what this says is that my y values must be positive. So on the right side of this graph, we're good. All my y values are positive. But on the left side of the graph, I can't have these be negative, so it becomes the positive versions of those numbers. It just takes that and flips it so that we always have positive y. So one indicator that we can really pick up on with these graphs is that my y values are always going to be positive. If you have a graph where the y values are not positive, then it's not the absolute value of f of x. Remember that f of x is just another way of writing y. So it says my y values must be positive. Here, doing slightly differently, we're saying the function for the absolute value of x. So what that means is that if I'm dealing with an f of 1, it's still going to be f of 1. But if I deal with f of -1, I can't have a negative in there. That's going to become the absolute value of -1, which would be f of 1. That means, that means that any of my values that were using negative x values are going to be a reflection of the positive x's instead. So if I had, say, a graph like let's go with something like this. My x values are positive to the right of the graph, so these are all okay. These are fine. But my x values that are negative, like all of these points, they're going to become the positive versions of themselves. They're going to become the positive x versions of themselves. So if I go to x equals -1, I know that my f of -1 is up here. But my x of +1, my f of x of +1 is right here. So it's going to be a reflection of that. What this is going to do is it's going to take all of your positive x values, all of the points that are on the right side of the y-axis, and reflect them across that axis. So it's going to become a reflection of these points, like so. So let's see how that applies to some of these graphs. Let's start with the graph they give us. Sketch the graph of f of x equals -x plus 3 squared plus 4. So we know from our parent graph transformations that this is a parabola. It's going to be facing down because of this negative. It's going to shift its vertex to the left 3 and up 4. So it'll look a bit like so, like that. And after that point, it gets a little bit like so. Let's make sure, because this is going to go 3, and we'll go 1, 2, 3, 4, 5 there, 5 there. It's more accurate. It'll help us identify these graphs a little bit better. So let's use this right here. And this right here as well. Okay, so that's our parent graph. Always good to see that. Now, this is just our parent. Let's break this up as r. Let's do our absolute of f of x. That one's a little bit easier. Remember, this means that this is the absolute values of y. So all of our y values must be positive. So on this tip of the iceberg, we're all good. But then these guys become, these points all become negative. So if these points are negative, we need to make them the positive versions of themselves. So we're going to have a reflection. These guys are all good. And this will go. So we've got this W pattern that shows up because it bounces off the x-axis. We can't have any negative y's, so they become positive y values. The other graph that graphs that we'll be looking at is the transformation of absolute value of the x. Now again, that means that all of my positive x values are perfectly acceptable, but my negative x values are going to become reflections of those positive x values. So it should have crossed right here. That means that these points are perfectly valid, and we're going to take those points and make a reflection across the axis of those points. So this is going to be your f of absolute of x. It's going to be the points that are reflected across the y-axis of your positive x values. So in this lesson, in these assignments, and also on the test, you're going to have to be able to identify your parent function. We've gone over a bunch of our parent functions, including the parabolas and our semicircles and our root functions, and then apply these absolute value rules. Again, positive y's only, reflection of the positive x's.